So here we need to evaluate the following polynomial at x equals 1.37. In part A, we need to use 3-digit arithmetic with chopping, and we also need to evaluate the percent relative error. While in part B, we need to repeat part A, but we need to express y as the following. And we also need to evaluate the error and compare it to with part A. Well, let's start with part A. So to find the value of this polynomial at x equals 1.37, we need to find x cubed, 7x squared, and 8x. So let's start with x cubed. So x cubed equals 1.37 cubed, which equals 2.571353. But here we need to do 3-digit chopping, so that means that x cubed equals 2.57. Great, now let's do the same thing with 7x squared. So 7x squared equals 7 times 1.37 squared. This equals 13.1383, and since we use 3-digit arithmetic, this equals 13.1. Well, and now we need to find 8x. So 8x equals 8 times 1.37 equals 10.96, and again we do the chopping and we get 10.9. Well, now let's just substitute these numbers for x cubed, x squared, and x in our polynomial. So we get that, I'll just copy paste this, that our polynomial equals x cubed, which is 2.57, minus 7x squared, which is 13.1, plus 8x, which is 10.9, and minus 0.35. And we get that this equals 0.02. Now we need to find the exact result. So the result without using 3-digit chopping. So y of 1.37 equals 2.571353. So we use the real values instead of those that we chopped. So this minus 13.1383 plus 10.96 minus 0.35, and this equals 0.0430. Wait, let me move this a little bit. 0.43053. And now we can find the percent relative error. So the percent relative error equals the exact result minus result that we got with 3-digit chopping and divided by exact result. So 0.04053 minus 0.02 over 0.043053 and multiplied by 100%. And this equals 53.54%. So we get quite a big percent relative error here. It's more than 50%. Now let's look at part B, so we can compare the errors in them. So in part B, we have our polynomial looking like this. So let's start by calculating x minus 7 times x. This equals 1.37 minus 7 times 1.37, and this equals negative 7.7131. Again, we do 3-digit chopping and we get that this equals negative 7.71. Well, now we need to calculate x minus 7 times x plus 8 times x. So we get negative 7.71 plus 8 times 1.37, and this equals 0.3973. Again, we do 3-digit chopping and we get that this equals 0.3397. Well, now we need to subtract 0.35 from 0.397. So we get that y of 1.37 equals 0.397 minus 0.35, and this equals 0.047. Well, now let's calculate the error. So it equals, again, we take the same exact value as in the part A. I will just copy paste it, minus the value that we got, which is 0.047, and then we divide it by the exact result again. So here we get and multiplied by 100%. So here we get negative 9.16%. So we see that error in part B is much smaller than error in part A, so we can write it down as error in part A is bigger than error in part B.